Okay, let's do one more for flatten binary tree to linked list. So it's not really a linked list, but the flattened version looks like a linked list. And the way they should be put is in the same order as pre-order traversal. So pre-order traversal is root to left to right. So we have root to left, and then this becomes a new root. So we have left and then right. So we just follow this pattern, and then we get this flattened. And the way we obtain the flattened is by setting left child pointer to be null. So that means all of them will have null. So logically, they want to put them in pre-order traversal. So I tried that, but it didn't work. The reason is I tried with root, and then I got root that left, and then I saved it somewhere. It has a value of 2, and then I said root that left is equal to null. So at this point we have 1, and then this is null, and then root the right is whatever we saved. So we made this. But the moment we do this, root the right is equal to 2, we are losing all of them, everything on the right. So it's not the correct method. Instead of doing a pre-order traversal, we have to do reverse pre-order traversal. So this way we can keep the pointer that we need. So that means we are going to go through all of them, we have to go all the way to the end. So very far right one. But actually, before we do that, I'm gonna probably add one more here. So it will look like this. So we are at this point. So we can say 7.left is equal to null, and then 7.right is also equal to null. So we created 7. All of them are null. And then now that we processed right, we can process left, which is 6. And before we leave this iteration, we can do some previous value is equal to the current root, which is 7. And then when we look at 6 star right, we can set it to previous value. So we get 6. And then we can do 6 star left is also equal to null. So this is null. So we can repeat this process. And we said 6 star right is previous, and then 7 star right is null. So that means that should also be previous, and then the initial value of previous should be null. So using this method, we can solve the question. So we do need tree node previous is equal to null, and then flatten root.right, and then flatten root.left. The order matters because this one allows us to achieve reverse of pre-order traversal, and then we can do root.right is equal to previous, and then root.left is equal to null, and then previous is equal to root. All right, and we actually need to do one more thing. So let's just follow our method. Flatten root.right and then root.left. So we have flatten 5 and then flatten 2. So this will recursively get called before this one is executed. So it will get flatten the right, which is 7, and then flatten the 6. And then this will also get recursively called, but this one has null and null. So we are essentially doing flatten null and then flatten null. But if you do null.right, it's going to throw error. So we do need some statement that ends recursion. So if root is equal to null, simply return. Okay, let's run the test. Okay, let's submit. Okay, that's it.